Okay, now we're done with the Gauss-Jordan elimination. We will move to the next method in solving system of linear equation, which is the Jacobi method. So Jacobi method is actually an iterative method in solving system of linear equation. So Jacobi method is invented by Carl Gustav Jacob Jacobi. So Jacobi iterative method is considered as an iterative logarithm which is used for determining the solution for the system of linear equations in numerical linear algebra, which is diagonally dominance. Diagonal dominance means that for each row, the absolute value of the diagonal term is greater than the sum of the absolute values of other terms. So the Jacobi method sometimes converges even if these conditions are not satisfied. So until it converges, the process is iterated. So this is an iterative method. So we need to iterate our equation until we get our values for our variable. This method makes two assumptions. First, the system given has a unique solution. So pag sinabing unique solution, we have only one specific solution set exists for a given solution. And yung pangalawa, the coefficient matrix has no zeros on its main diagonal. So para ma-apply natin itong Jacobi method, dapat yung main diagonal natin has no zero element. So if any of the diagonal element is 0 or 0 or are 0, then row or column must be interchanged to obtain a coefficient matrix that has non-zero entries on its main diagonal. So this two makes the assumption in our Jacobi method. So to find values for Jacobi method, we are going to make an equation based on our matrix. So to find the values of variable in Jacobi method. Then each element is solved and an approximate value will be put in this equation. So this process will be iterated until it converges. Jacobi method, uulitin natin siya. We will continue our iteration until we have two successive approximations are identical when rounded to 3 significant digits. So dun pa lang tayo mag-stop pag meron na tayong two successive approximation na parehas yung sagot natin, stop na natin yung ating iteration. And that will be now our values for our variable sa ating matrix. So, i-iterate lang natin siya. So, okay, so let's have an example for Jacobi method. So we need to solve the equation x plus 5y is equal to 16 and 3x plus y that is equal to 11 using the Jacobi method. So for our solution, we have this two equation. The 5x x plus 5y that is equal to 16 and the 3x plus y that is equal to 11. If we are going to look our equation, the coefficient matrix of the given is not diagonally dominant. So therefore, we arrange the equation such that the elements in the coefficient matrix are diagonally dominant. So ito kasi, mas mababa itong diagonal natin kaysa dito sa element natin dito if we have a matrix coefficient of matrix. So we need to interchange these two uh, equations. So pag in-interchange natin yan, we have this now our equation. Yan. Pwede na siyang diagonally dominance na siya kasi mas malaki yung 3 in our variable here and mas malaki yung 5 in our variable here. Yung etong diagonal natin is diagonally dominant na siya. So from this equation, we can get that in this equation 1, that is x, makukuha natin yung variable x natin if we manipulate our equation, that is equal to 1/3 of 11 minus y. And if we manipulate our second equation, makukuha natin yung ating equation for y, that is equal to 1/5 of 16 minus x. So, yan yung magiging two equations natin. Yung susunod ni steps, yung solution natin is to continue iterate until we have two successive approximation are identical when rounded to 3 significant digit. So, if we have this now as our equation, ito yung equations na natin. Okay, so we need to iterate that. So, our first approximation, yung first approximation natin is we have to assume our value for x and our value for y. So, yung first assumption natin dito is our value for x is equal to 0 and our value for y is equal to 0. And we will be substituting this value in our equation. So, in first approximation, i-substitute daw natin yung value natin na x and y sa ating equation. So, our x now, yung magiging x1 na natin, yung first approximation na natin is equal to 1/3 11 minus, ano yung value natin ng y? That is 0. So, our value here is 11 over 3. So, ang value natin ng y is equal to 1/5, 16 minus value for x is equal to 0. So, we have 16 over 5. That will be now our value for our first approximation sa ating x and y. Okay, let's proceed to the second approximation. Kasi sabi natin, yung iteration natin, mag-stop lang siya pag parehas yung magkasunod na iteration natin. So, ngayon, ang second approximation natin, ano na ngayon yung value ng x and y natin? Kasi dito sa first approximation, ang value ng x and y natin is we have assumed that our value of x and y is 0. So, sa second approximation, ano na yung magiging value natin for x and y? So, yung magiging value na natin dito sa second approximation ng x and y is equal doon sa sinolve natin dito sa ating first approximation. So, we have yung x natin dito is equal to 11 over 3 and yung y natin is 16 over 5. So, pag meron na tayong value ng x and y, para makuha na natin yung value ng x sa second approximation natin and y sa second approximation natin, we need to substitute this value in our equation. So that is, so we have here 1/3. 11 minus our value, 16/5. And for y, we have 1/5. 16 minus ang x natin is 11/3. So our value here in x in our second approximation is equal to 2.6. And for our second approximation, we have 2.4667. So yan yung magiging value natin ng second approximation for variable x and y. So yung susunod na approximation natin, yung x3 and y sub 3, yung magiging value na natin dito sa x and y natin sa ating equation will be our value here in the second approximation. So yung magiging value na natin ng x and y is 2.6 and 2.4667. So, continuing our approximation, yung third approximation natin, so we have that, our second approximation, and then for our third approximation, yung value natin ng x and y is the value we have solved in our second approximation. So, we have yung y natin is 2.46667 and yung x natin is 2.6. So, for our third approximation, isa-substitute natin itong value doon sa ating original equation. That is to solve for the x sub 3, yung x natin for our iteration, yung third approximation natin. So, we have 1/3. 11 minus y, yung y natin is 46667. That is equal to 2.84444. So, kindly check my calculation if it is correct. So, we have y3. Ang equation natin is 1/5 16 minus x. That is 2.6. That will now be 2.68. So, this will be now our value in our third approximation, yung third iteration natin. So, in our fourth iteration, or approximation, so, hindi pa wala pa tayong 2 consecutive ni iteration or approximation na identical yung sagot natin. So, hindi pa tayo mag-stop. Mag-stop lang tayo if we have 2 successive approximation that are identical. Okay. So, yung fourth approximation mo, yung value ng x and y mo is yung nakuha mo doon sa third. So, yung x natin is 2.8444 and yung y natin is 2.68. And then, substitute again this value in our equation para makuha mo yung fourth approximation. So, we have 11 minus 2.68 yung y natin. So, yung value natin dito is 2.77333 and yung y sub 4 natin is equal to 1/5. 16 minus x, that is 2.8444. So, that is 2.63111. So, yan na yung magiging fourth approximation natin. Ito na yung value natin ng fourth approximation. So, pagdating natin ng fifth approximation, yung x na naman natin and y is this value. So, pag tinitignan nyo yung third approximation and fourth approximation, hindi pa sila magkaparehas. Hindi pa natin i-stop yung ating iteration. So, stop lang natin yung iteration natin pag magkaparehas na yung 2 consecutive approximation. So, that is our fourth approximation. And then, for our fifth approximation, yan. I-substitute lang natin yung values natin dito sa y, yung nakuha natin sa fourth approximation. And then, dito sa 5 yung nakuha natin sa fourth approximation dito sa y. So, we have 2.63 and 2.77. And we need to solve that. Ito yung lalabas na value. So, pag tinitignan natin, hindi pa sila parehas, 2 consecutive. So, 6 approximation, susunod na iteration natin, yung value ng x and y natin, yung y and x natin dito, is yung value natin dito sa 5th approximation. So, substitute lang natin ulit. Ito na yung makukuha nating values. And then, you have to repeat that process until we have 2 consecutive na approximation na magkaparehas. So, pag inulit-ulit-ulit natin yan, so we have 8 approximation. So, pag tinitignan natin yung 8, 7, and 8 approximation natin, yung 7 and 8 iteration natin, magkaparehas na yung ating value for x and y. So, we have 2.785, 2.785. So, magkaparehas na. Diba? And then, approximately equal na sila. And then, 2.643, 2.643. So, kahit hanggang third decimal tayo. So, that is 2.3, 2.640. So, parehas sila. Approximately, parehas yung dalawang, yung 7th iteration, approximation natin and 8 approximation natin. So, magkasunod, consecutive. So, pwede na tayong mag-stop. So, kung gusto nyong mas accurate yung sagot ninyo, you can continue iterating hanggang talagang magkaparehas. Tignan nyo na magkaparehas. Diba? So, yan. We can stop now here kasi at least magkaparehas na, approximate, magkaparehas na yung 7th iteration or approximation natin and 8th approximation natin. So, we can stop now. So, our value for x now is 2.78566 and yung value natin ng y is 2.643. So, to summarize our solution, we have here the tabulated form. So, ito yung first iteration natin. Ito yung value natin. Yung second, ito yung value natin. Hanggang sa medyo magkaparehas na yung value ng x and y natin, nag-stop na tayo. Mali ito. That is 2.785 dapat dito. So, mali yung dito. Paki-check ito. Ito. Dapat 2.78566. Itong 8. Dito. Okay. So, that's for sample number 1. So, let's have another example for example 2. So, we have to solve our equation using the Jacobi method. So, we have here an equations. So, kailangan natin ng w, x, y, and z. That's our variable. So, looking at our equation, the coefficient matrix of the given system is diagonal dominant. So, therefore, yung Jacobi method natin is applicable. So, ito, matataas yung value na. Ito yung diagonal natin, di ba? O, yan. Diagonally dominant siya kasi ito, pinakamataas 14. Dito, pinakamataas 22. Ito, pinakamataas na coefficient is 17. And ito, pinakamataas na coefficient is 18. So, diagonally dominant sila. Kasi sila yung coefficient sa matrix na may mataas na value. So, from this equation, we can get now the equation for solving w, solving x, solving y, and solving z. So, makukuha na natin yung steps na yan. So, steps. Makukuha na natin yung equations sa w, x, y, and z. So, for first equation, since w yung dominant dito, if we manipulate this equation, makukuha natin yung equation natin for W that is equal to 114 of 57 minus x minus 7y minus 4z. And the same for x, makukuha natin yung equation natin that is equal to this equation, 36 minus w minus 8y plus 8z. So, dito din nakuha yan. And for our third, yung y naman natin, that is equal to 1 over 17. 48 minus 2w plus 8x plus 3z. And our last equation for z variable, that is 1 over 18. 24 minus 7w minus 2x plus 7y. Yan. Yan na yung magiging equations natin to solve our variables. So, yung first approximation natin is, or yung first iteration natin, we assume that the value of x, y, w, x, y, and z is equal to 0. So, pag 0 ang w, x, y, and z natin, pag sinubstitute natin itong value nila na 0 dito sa ating equation, which is this, makukuha natin yung first approximation value ng w, first approximation ng x, first approximation ng y, and yung first approximation ng z. So, yung first approximation natin, W1, that is equal to 1/4 57 minus x is equal to 0. Minus 7 times y, that is equal to 0, 0. Minus 4 times z, that is 0, 0 pa rin. So, yung W1 natin dito is equal to 4.0714. So, kindly check if my calculation is correct. And then, yung x1 natin, ano yung magiging value ng x1 natin? So, i-substitute natin itong value ng w, x, y, and z dito sa ating equation sa x dito. So, pag sinubstitute nyo dyan, ang value natin for x1 is equal to 1.6364. Next, for y1, substitute ulit itong value dito sa y equation natin. Makukuha natin dyan is 2.8235. And for z1, that is equal to, so, ito yung equation natin, substitute lang natin itong value natin dito, i-substitute natin dito. So, ang value natin for z1 is equal to 1.333. So, yan. So, uulit-ulitin lang natin ito. However, yung pangalawang approximation natin, imbes na yung 0, 0, 0 yung gagamitin nating value ng w, x, y, and z, ang gagamitin natin sa next approximation is the value in our first approximation. So, yan. So, yung gagamitin natin sa second approximation, yung nakuha natin sa first approximation. Ang gagamitin natin sa third approximation is yung value natin sa second approximation. So, ganun. Paulit-ulit lang yan hanggang sa may 2 consecutive na parehas yung sagot natin. Okay? So, yan yung ating first approximation. So, pagdating sa ating second approximation, so, yan yung value natin. So, pagdating sa ating second approximation, yung W2 natin, ito pa rin yung ating equation. Ang x, y, and z lang natin is yung value dito. Yan. So, substitute lang natin yung nakuha natin na value for w, x, y, and z doon sa first approximation para makuha yung second approximation dito sa ating equation. So, if we substitute these values here, makukuha natin for w for second approximation is equal to 2.1618. Yung x2 equal to 0.9094. Yung y2 equal to 3.3499 and yung ating J2 that is equal to 0.6662. Yan. So, pag sinubstitute natin itong value dito sa ating equation, ito yung makukuha natin na equation. So, second approximation. And then, uulitin na naman natin, ganun. Ganun lang yung process sa Jacobi method. So, ganyan lang yung, paulit-ulit lang yung gagawin natin. Hanggang makuha natin yung dalawang magkasunod, dapat parehas bago tayo mag-stop. So, punta tayo dito. That is our third approximation. Yung value natin ng x, y, and z is yung nakuha natin doon sa second approximation. So, ito na yung mga yon. Sinubstitute lang natin dito sa ating equation, makukuha natin yung values na ito. And for our fourth, yung value natin doon sa third, sinubstitute lang natin dito itong mga yon para makuha natin yung fourth approximation natin. So, for the fifth, yung nakuha natin dito, substitute natin dito sa equation, makukuha natin yung fifth approximation. And so forth and so on. So, 6, hindi pa rin sila magkaparehas. So, hindi pa natin i-stop yung ating iteration. So, magsi-7th na siya, mag-8 na siya, magna-9 na siya, hindi pa parehas yung, hindi pa siya approximately na parehas. So, ituloy natin yung approximation natin. So, 9 na tayo, we have 10. Nag-10 na tayo. So, paulit-ulit lang yung gagawin natin. Yung W, X, Y, and Z equal to the values obtained from the previous approximation. So, yung nakuha natin sa 9, at sinubstitute natin dito sa 10. So, meron tayong values. So, sabi ko nga, paulit-ulit lang itong, kasi nga iteration ang method natin. So, 11 iteration, this will be the values. 12 iteration, this will be our values. And we have 13 iteration, we have these values. 14th iteration, we have these values. And pagdating natin sa 15th iteration, we have values here that is approximately equal to this value. So, we have now two consecutive iteration that have approximately yung sagot natin. So, we can stop now our iteration dito sa Jacobi method. So, our value now for W, X, Y, and Z will be now this values. So, we have 1.76334 W. For X, we have 0.993. For Y, we have 3.4114. And for Z, we have 1.8632. So, ito yun na yung magiging values natin for W, X, Y, and Z. Kasi nga, pwede na tayong mag-stop kasi parehas na sila, approximately equal na. Meron na tayong two consecutive approximation that have the values of W, X, Y, and Z that is approximately equal. So, yan. Kaya nag-stop tayo sa 15th iteration. Pag hindi pa sila equal, itutuloy natin hanggang mag-equal yung ating two consecutive. Okay? So, hanggang 15th iteration, we have here the summary iteration in tabulated form. So, ito yung mga values natin na nakuha pag nag-iterate tayo hanggang dito. Medyo equal na siya, approximately equal na siya. So, pwede na tayong mag-stop sa ating iteration. And the value for W, X, Y, and Z will be now this value in our 15th iteration. So, that's for the Jacobi method.